Hello, this is Dr. Chen, and this is your lecture for the chapter on validity. Without further ado, let's get started. So what is validity? Validity is simply a property of an assessment tool that indicates that the tool does what it says it does. And if it does that, then the test scores have meaning. In other words, at least according to the American Psychological Association, validity is the extent to which the inferences that we can make from a test are appropriate, meaningful, and useful when used with the population in which we intend to use it with. So it's pretty simple, but also not so simple in that sense. And it's also related to what we talked about in the previous chapter. It might be useful to mention this very close relationship between reliability and validity. And so if you recall, reliability from chapter 3 is basically to the extent to which a test is able to measure something consistently. So the maximum, and this is actually at the end of a chapter, it very quickly mentions this, but I thought it might be useful to mention this at the front end as well, as I try to talk about the importance of discussing validity. The maximum level of validity that you're ever going to get, regardless of whether it's content, criterion, or construct, and I'll talk about those types of validities in just a little bit, but the maximum level of validity that you're going to get is going to only equal the square root of the reliability coefficient. So for example, if your reliability coefficient for, say, test retest, for a particular measure that you just developed is, say, 0.87, the validity coefficient, or the correlation of that same test with another established test, cannot be larger than 0.93. So how do we get 0.93? 0.93 is basically the square root of 0.87. What this means is that the validity of a test is necessarily constrained by the reliability of that test. So you need to be reliable first before you can be valid, essentially. So that's why it's so important to talk about reliability first, but it's also important to talk about validity because it's very possible for you to be consistently wrong. So what are the three different types of validity? So we have content validity, criterion validity, and criterion validity is split into predictive and concurrent, and then we have construct validity. And technically, construct validity is divided into discriminant validity and convergent validity, but I'm not going to emphasize too much on that. I'll talk more about that when we talk about the multitrait-multimethod matrix. But for right now, let's talk about content validity first, and then criterion. So content validity, what is it? Content validity assesses the degree to which the sample of items truly reflects an entire universe of items that you are wanting to measure. So in other words, is the collection of items on that test a fair representation of all of the possible items that you could possibly put in your test? Ideally, we would want your items to be a random sample of the universe of content that you could possibly access. This means that if your test does have content validity, it is a fair representation of all the possible questions that you can ask. It's a fair representation of the content that you're interested in. So for the exam, make sure you know what content validity is and be able to recognize a demonstration of content validity when it is being described to you. So one quantification of content validity that's provided by your textbook is, say you have a panel of expert judges, and lots of people actually do this. They create an instrument, and as an initial validity check, after generating or creating all of the questions on this questionnaire, they invite a number of experts who know a lot about the domain of interest, the domain that you are trying to assess, and basically get them to kind of pick and choose or make judgments as to whether each item is essential or is appropriate to the domain that you're wanting to measure. So the equation is basically this. For each item, you would subtract the total number of judges divided by 2, so n divided by 2, from the number of judges who selected this particular item. So let's say you got 10 items, you get this person to judge this particular item first. You do basically the number of judges who selected the essential questions minus the total number of judges divided by 2, and take that, divide that by n divided by 2 again. So for each item, so say if you got 10 items, you get a CVR or content validity ratio. So you should have 10 content validity ratios for 10 items. How do you interpret the result? So any value that is less than 0 means that there is less than adequate agreement that this particular item is essential to the variable of interest. So you want values larger than 0 essentially. So based on this, you can get a pretty decent idea about which items seem to have the level of content validity that you would need before you do further tests on that particular scale that you are trying to develop. So for the exam, for the quiz, know what the content validity ratio is and how it's calculated. Moving on to criterion validity. So criterion validity, on the other hand, assesses whether a test reflects a set of abilities in a current or future setting, as measured by some other test or evaluation tool. So if the criterion is taking place in the here and now, we talk about concurrent validity. If the criterion is taking place in the future, then it becomes predictive validity. Quick note, since we're talking about criterion validity, I'm also going to point out right now, and I'll point out again later, that the difference between criterion and construct validity, a lot of times it's based on the intention of the investigator or where this testing is coming from. So if the correlation that you are testing is to test a scientific theory related to a construct, then it probably is construct validity. But if the correlation that you are testing is not necessarily to test a scientific theory, you just want to know if your new measure correlates with this other criterion or this other measure, then it probably is criterion. And you'll notice in the exam quiz, I'll try to make that as explicit as possible. So you can think about criterion validity as being a little bit more pragmatic, and construct validity as being a little bit more conceptual and a little bit more complex than just criterion validity. Let's talk about concurrent validity. So we're still in the realm of criterion validity. Concurrent validity assesses whether a test reflects a set of abilities at the current moment. So, for example, if you develop a test that you think does a good job of measuring culinary skills, and this is the example that's described in your chapter as well. So, skills related to culinary skills could include knife technique, pastry crust creation, and so on and so forth. My wife probably knows a lot more about that than me because she's just awesome at doing this. And so, you develop a test that you think does a good job of measuring culinary skills, and you call it the Cook scale, COOK. You then try to correlate this scale with an already established grading rubric that judges say already use to rank each student on a scale of 1 to 10 on overall ability in terms of their culinary skills. So, assuming that you do have the judges rank the students on the Cook scale and on this other already established scale that the judges use to rank students, then if both ratings are obtained at the same time, then it is concurrent as opposed to predictive. In addition, given that this correlation is not necessarily conducted to test a relationship that is based on scientific theory, it is criterion as opposed to construct. Predictive validity, in contrast with concurrent, is when the criterion changes from the here and now to a score that is based in the future. So for example, you may try to correlate your Cook scale with a student's success of being a chef, maybe 5 years down the road. And you code this as 1 if the student owns his own restaurant for at least 1 year, or 0 if the student does not own his restaurant 5 years later. So because the criterion pertains to something that happens in the future, it is predictive as opposed to being concurrent. And a high correlation indicates predictive validity, and a low correlation indicates a lack thereof. So hopefully all this is pretty straightforward so far, because I want to talk a little bit more about that criterion. So there are a couple of things that you should know about the criterion. So it may be obvious to you right now that the key to establishing either concurrent or predictive validity is the quality of the criterion, obviously. If your criterion is not accurate or a meaningful reflection of what you want to measure, then whatever correlation it is that you're getting means nothing. So if the grading rubric that judges already use to rate the overall culinary skills of students, if that criterion was basically a wash, if that was not valid, then even if you got a strong correlation between your Cook scale and that established grading rubric, that correlation doesn't mean anything, because your criterion needs to be of good quality. In practice, what most researchers typically do is they would pick a criterion that already has an established validity as described in the literature as being tested by other researchers as well. Another thing that you should know about your criterion, is the concept of criterion contamination. So criterion contamination is what happens when you have other factors influencing the validity of your criterion itself. So in other words, if your criterion is being influenced by other factors, so this space over here in this Venn diagram, if your criterion is not being influenced by other factors, that are not relevant to your criterion, then your criterion is sorry, let me say that one more again. I think I'm confusing myself over here. If your criterion is being influenced by other factors not relevant to your criterion, then your criterion is basically contaminated by these extraneous types of influences right here. One example, one way in which you could have a very obvious case of criterion contamination is if, let's say, if your judges are rating these students on some external criterion, and say for whatever reason, your judges also know that you are trying to correlate your Cook scale with this external criterion that you're trying to correlate. And them being your friends, maybe they decide to since they know what the scores in the Cook scales are, they then also give a similar score on your criterion scale. Now, if that were to happen, obviously your criterion is being contaminated, because some of the variability in the scores in your criterion is being affected by knowledge of what the predictive score is and knowledge about what you're trying to do. So it's stuff like that that you kind of want to keep in mind to make sure that your criterion is not contaminated. And if you keep these things in mind, that basically what you want is this middle ground over here, that what you intend to measure with the criterion and what your criterion is actually measuring, you kind of want the stuff here that is in the middle. So for the exam, know what criterion contamination is, which is basically when your criterion is measuring other things that are not relevant to what it is that you're trying to measure. And know also what makes a criterion a good criterion, which is basically when your criterion is measuring, is giving you a meaningful reflection of what it is that you're trying to measure. moving on to construct validity. So to understand construct validity, we have to understand what a construct is. So a construct is basically an abstract concept or idea that is generated from a scientific theory. So construct validity is a demonstration of the validity of the theoretical implications of the construct that you are trying to validate. It's pretty easy to confuse between criterion and construct validity because you almost always see researchers using the same correlations to demonstrate construct versus criterion, which is basically correlations between at least two variables. As said before, the important distinction between construct and criterion lies in the intention of the researcher. So for example, is this researcher trying to test something that is directly coming from scientific theory, or is this researcher mostly interested in seeing if there is a strong correlation between two variables, pretty much very little or no emphasis on theory development at all. So in the quiz exam, you'll see me trying to make distinction clear for you. So be on the lookout for those types of keywords. So know the difference between construct and criterion. So constructs are derived from scientific theories. If you don't know what scientific theories are, the definition is they're basically a system of interrelated ideas used to explain a set of phenomena. And there are implications to the theory that we can test in terms of construct validity. So for example, you might have a theoretical model of aggression that proposes that aggressive men are more often in trouble with authorities than are non-aggressive men. And based on your review of, say, the criminology literature, right? Because you're trying to make this new self-report skill that measures aggression as an outgrowth of your theoretical view of what the construct of aggression consists of. And after reviewing literature, you find out that basically males who are aggressive have a higher level of involvement in crime, they have a low quality of personal relationships, and they have a higher frequency of physical aggression. So how do you demonstrate construct validity? Well, what you do is once you've developed your measure, you then try to correlate your measure with these outcomes over here. So to the extent to which your measure is able to predict actual level of involvement in crime, to the extent to which your measure is able to predict the actual quality of their personal relationships and the frequency of physical aggression, the stronger the correlations, the stronger your evidence for a construct validity. Now, on the other hand, because remember, when it comes to construct validity, we're examining different theoretical implications of the construct that you're trying to measure over here. On the other hand, you don't find in literature, in scientific literature, a lot of strong relationships between your conceptualization of aggression and, say, whether or not they complete high school. And you've also found that other researchers have found that their employment status has got very little to do with their aggression levels, and whether or not they like shooting guns has very little to do with their aggression levels too. And so to demonstrate construct validity, or specifically under construct validity, there is convergent and discriminant. So to demonstrate discriminant validity, you would hopefully expect to find low to zero correlations between aggression and these constructs that are not supposed to be related to it. So this is discriminant validity, which is a type of construct validity, and this is convergent validity, which is a type of construct validity. All right, so one comprehensive way to demonstrate construct validity is to use the multitrait-multimethod matrix. So let's say you want to establish the construct validity of the scale that we just talked about. We'll call it the fight scale. You would use a number of different methods and measure a number of different traits to help us parse out the variability that may be coming from, sharing the same method or sharing the same trait. So let's say for this example, we use three methods. You use an observational tool, a self-report tool, and teacher ratings, and all three methods that are then used to measure these traits. Aggression as measured by your measure, intelligence, as well as emotional stability. And what you get from that is basically a matrix called the Multitrait-Multimethod Matrix. Let me check to see if the table in a textbook is actually correct. Okay, yeah, just double checking. All right, so it's the same table over here, just formatted slightly differently. So you have observation, self-report, teacher ratings, aggression, intelligence, and emotional stability. Similar type of configuration over here: observation, self-report, teacher ratings, aggression, intelligence, emotional stability. So a bunch of correlations over here, but these would be what the pattern of correlations that is being described over here is what you would expect if your measure has construct validity, especially when it comes to convergent and discriminant validity. So let's look at the low correlations over here, right? So the low correlations are for correlations between different methods measuring different traits. So measuring, say for example, aggression through observation, and you correlate that with intelligence as being measured by self-report. Obviously, you would not expect any type of correlation going on over here. If you do, then something weird is going on. These correlations over here, the ones that are lows, is what we would typically refer to as some evidence of discriminant validity. Now let's look at the moderate correlations over here, the ones in brown. So moderate correlations is what you would expect to see between the same methods that are being used to measure different traits. So say for example, you want to correlate aggression as being measured by observation and intelligence also being measured by observation. Now you would expect a correlation that is higher than the previous type of configuration because they share a common method. Same thing over here. Intelligence as being measured by observation and emotional stability as being measured by observation. You should expect some correlation, but hopefully not too high, because you don't want your measures to be correlated simply because you're using the same method. What you want is basically high correlations between the different methods that are being used to measure the same traits. So aggression as being measured by observation, you would want this to be highly correlated with aggression as being measured by self-report and aggression as being measured by teacher ratings. This is what we would call convergent validity, where a high value in these types of correlations would validate the use of your new method as being validated through other different means. And then you would have the highest correlations over here, basically for the same methods measuring the same traits. In other words, these are your reliability coefficients, just like what we talked about in the previous chapter. So for the exam and also for your quarterly assignment, you want to know basically the types of validity that you would expect to see in a multi-trait, multi-method matrix, all the way from low correlations to moderate to high to very high, and what all these correlations basically mean. All right. Here is a slide that basically summarizes all of what I just talked about. And so just know that at the end of the day, the fundamental logic between the fundamental logic behind the multi-trait, multi-method matrix is that correlations between different methods being used to measure the same traits should be higher than the correlations where you're using the same method measuring different traits. So what do you do if you cannot establish validity? Well, if you're not getting the say, content validity coefficients that you would need, then you might need to redo the questions on your test to make sure items truly are a random sample of the universal content that you're wanting to measure. If you're not getting the correlations that you need for criterion validity, then you might want to check to see if your criterion truly is an accurate and meaningful measure of what you're trying to assess, or you might need to redo the questions on your test, assuming if your criterion is pretty good. If you're not getting the correlations you need for construct validity, then you might need to take a closer look at the rationale or the theoretical rationale that underlies your test that you just developed. Or maybe you just might need to think about this just a little bit more. So that at the end of the day, you want to address these different types of validities to make sure that your measure is measuring what it claims to measure. So these again are the three types of validities. Know what these three different terms mean: content, criterion, and construct, including what you'd expect to see in a multi-trait-multi-method matrix if you have construct validity. I would recommend over-learning them, especially for the parts that relate to the multi-trait-multi-method matrix. So that's pretty much it for this chapter. So now that we understand the basic concepts of validity and reliability, next week our task is to understand test scores for the next chapter, which is chapter 5. We'll talk about what are norms and what are percentiles and what information do those things give us, assuming that our tests are valid and reliable. That's all. And hope you have a good rest of the week and have fun with the assignments.